Hi friends, welcome to our channel. Here let's look at this problem. Check if grid can be cut into sections. This problem again is a interval merge problem. So we are going to follow our previous ideas in the interval merge problem playlist. So here basically we are given a number of rectangles represented by this one, right? So this is the bottom left coordinates, and this is the top right coordinates. So we want to check if we can make cuts such that either two horizontal or two vertical cuts can be made such that each of the three resulting sections formed by the cuts contains at least one rectangle, and every rectangle belongs to exactly one section, right? So here, if you look at example 1, so you can see we can do horizontal cut. So this is cutting the y coordinates, right? So here is vertical one. So this is a false scenario. So here are the constraints. So let's look at the second one. The length can be as long as 10 to the power fifths, which means that we need to consider temp complexity. So with that said, let's look at the major idea. So first, we notice that, if touching, we are going to regard it as non-overlapping. So this is an important assumption. So the idea would be the following. So we can extract the x intervals and the y intervals, right? And then we are going to merge the overlapping ones, and then to see if we can have at least three merged intervals in either direction, x or y. If this were the case, either one of true will lead the result to be true, otherwise false. So here, for example, the first one. So let me use the first one. So here you are going to have x coordinate will be 1, 5, right? 1, 5. So 0, 2, and 3, 5. And 0, 4, right? So the y coordinate will be the first one, the third one. It's 0, 2, and 2, 4, and 2, 3, and then 4, 5, right? So now if we merge the ones with overlapping, let's maybe we can do a sort, for example. So here we are going to have 0, 2, 0, 4, and 1, 5, and 3, 5, right? So if you look at these, so 0, 2, they have overlap to 0, 4, and then also overlapping with 1, 5, and 3, 5. So if you merge, you are going to get 1, 5, right? Essentially 1. For sure, in this case, you cannot make two cuts. So now let's look at this one. So if you do sort, you're going to get, this is already in sorted order. So if you look at this one, 0, 2, and 2, 4, and 2, 3. So this 0, 2 with this starting with 2 actually are regarded as non-overlapping by the assumption of this problem. So we're going to have 0, 2, and then 2, 3, and 2, 4. So they overlap. So we get 2, 4. Similarly, 2, 4, and 4, 5 are regarded as non-overlapping. So we get 5, 4, right? So then you see there are three intervals. So you can put a cut at 2 and 4. So this is exactly the case, right? So in other words, you cut the y coordinates horizontally. So that is like this. So that's the problem. That's the major idea. So okay, so we're going to return true. So with that said, let's actually transform this problem into a typical interval merge problem. So how do we do that? You first track the x and y coordinates, right? So this is step 1. And then step 2 will be interval merge. So if one of the interval arrays yield, let's see, more than two merged intervals. The result will be true, return true. Otherwise, false. So now the comment is this. So merging interval is very classic. We can easily do it. So with that said, I guess you should be able to reduce this problem to an interval merge problem and writing the code. Now let me provide one sample code for this problem. First, we track the intervals. So let's see, first x intervals. So I'm going to use element. So I changed the rectangles to be capital R just for convenience of typing. So we're going to have E0 and E2, right? And then for E in R, right? And then similarly, you get Y array. So you're going to copy this one. Let's see. Change the indexing to be 1 and 3. So actually, you can print out this. See, X array, and then Y array. Let's print out. So yeah, if you look at here, you are going to get 15023504, this line, right? And then you have 022423 and 45. It's exactly this line, right? So now with that done, let me write a, because we need to check either X array or Y array, but let me write a hyperfunction to do it so that we can reuse the code. So let's call it merge. So you give me the array, so I want to merge and to check if I have enough resulted intervals, non-overlapping intervals. So let's get the length of this array. And then what we're going to do is, here I'm going to write using explicitly a stack, but in principle, you don't need to do this. The reason is that I want to do some print so that you can know what's the merged interval, what are the merged interval. So here, important thing is you need to do a sort. So here, typically, sometimes you need to write a key or sorting key, but here I just sort according to the first coordinates. So it's just like this, using the default behavior. So I put the array 0 into the stack. So this way of writing actually is very convenient. So now we are going to do a for loop for I in range. So we are going to start from index 1 and ending at index n-1, right? So we write n here. So then we can get the interval at the top of the stack, at the stack -1. So this way of writing guarantees the stack will not empty. Therefore, you can do this element retrieval. So the current interval will be array I, right? So now let's see, we've discussed two cases. If they're non-overlapping, we're going to put the current interval SE into the top of the stack. Otherwise, we need to merge the interval. So first, if S is greater than or equal to E bar. So this is important, this equality, because sometimes based on the problem assumption, you need to write strictly greater than at the end of the previous interval. So if there's no overlapping, so we are going to do stack append SE. That's the one. Otherwise, we need to merge the interval if S is less than E bar. So in this case, the merged one should be the smaller of the start is for sure S bar. The reason S underscore. The reason is that we have already sorted this array. Then the end will be the maximum of the previous end and the current end. So here is E bar. So now what we do is to pop the top element from stack, and then we do append operation for the merged interval, right? And then what we are going to do is to return if the length of the stack is greater than or equal to 3, right? Or you can write strictly greater than 2, right? So with this hyperfunction, actually we can quickly do the return. So we return merge X array or merge Y array. As long as one of the conditions is true, then the whole result will be true. If all of them are false, then we're going to return false. So let me first test it. Yeah, it passes the 3 given examples. Now let's look at the generic case. Yeah, it passes all the cases. So here, let me do some print so that you can know what's the result after merging. So let's see. Let's print the f. Let's print the. Before we sort, we can do this maybe. Print array after sort. This would be the array, right? Then we are going to print array after merge. So again, we are going to use the first example because we have walked it through, right? Yeah. So if you look at this one, so you see here. Let me. Yeah. So this one. So we get 0, 2, 0, 4, 0, 4, and 1, 5, 3, 5, right? So this is the one. So so this is the after. Let's see. We didn't. Let's see. After merge, so we should print the stack, not the array. Let me. Yeah. After merge, you are going to have 0, 5. That's here. So I think here I should write 0, 5, not 1, 5, right? So then the second one after merge, you have 3, 0, 2, 2, 4, and 4, 5. That's the right one. So that's the full logic. I guess with this print, I hope you have a very good understanding about the logic and about the pattern. So as a final comments, so we have a interval merge problem playlist in our channel. You're welcome to check out those problems for practice. Thank you for watching.